Okay. Okay. Yes. Send me message. Okay. Now okay, right? And on it, Joel, I asked. Now okay? Still same issue? Okay, great. If it's came any connection issue or any problem, let me know because today heavy rain, you know. Okay. Okay, what we discussing? Okay, last day I gave a summary of this lesson. Still lagging. Let me check my wife. Ah, video is cracking. Wait, let me check. Okay, how about now? Send me update. Okay, right? Okay, great. Okay, come to the lesson. Now, okay. Okay, today we have very important part, the extraction. Extraction. I told we have a summary of this lesson. We have three extraction method and three separation and identification method. Finally, we have three purification method. Today, our target to complete extraction method and separation chromatography techniques. Okay, that's the most important lesson. Most probably This time one essay question from chemistry part asking from this section, chromatography or extraction methods, chromatography techniques or extraction techniques. Okay, therefore today lesson very important, right? Okay, I gave a summary. What I gave in this lesson, we have three main parts. Actually, the secondary metabolites separation or secondary metabolites utilization process. Secondary metabolites utilized for whatever industry, medicine or cosmetics or whatever industry. We have three main steps. Three main steps. Secondary metabolites. We have three main steps. The first one is the extraction. The first one is extraction. The second one is separation and identification. Separation and identification. Identification. Separation and identification. Finally, purification. Okay, Rehlan, I will take it. Yes, extraction, separation and identification, and yeah, that's only we discussed. Last day there was an issue, I think, yeah, due to time, no? Due to time. Therefore, we did only summary. Okay, today actually we starting, Rehlan. Today actually we starting secondary metabolites, extraction, separation and identification and purification. No worries, you can understand from this part. Today, now video and audio okay, right, Rehlan? No any issue. Oh, great. Okay, extraction, separation and purification. Finally, sorry, separation and identification, purification. 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 Okay. Extraction. I told we have three main types of extraction methods. What are they? Revise. What are the extraction method? Solvent extraction. Solvent extraction. The first one, solvent extraction. Solvent extraction. Second one, pressing with wax. Pressing with wax. Pressing with wax. Okay, today I will explain one by one what are the steps, and I will give you real time practical understand, practical knowledge, and how to use and what are the steps and what are the careful points you need to remember. Everything I will explain today. Pressing with wax. Pressing with wax. Pressing with wax. Normally, pressing with wax method commonly used for essential oil extraction process. Essential oil extraction process. Final one, distillation. Distillation. Distillation, I told there are three main types of distillation. What are they? Simple distillation, steam distillation, and fractional distillation. Simple distillation, steam distillation, and fractional distillation. Right? Separation and identification technique. I told the main method, chromatography. Chromatography is a method. Chromatography is a method. Chromatography methods mainly three types. What are the types? Paper chromatography, thin layer chromatography, TLC, thin layer chromatography, and column chromatography. Column chromatography. Column chromatography. Paper chromatography, thin layer chromatography, and column chromatography. Purification. Finally, after identification, actually the identification means this the extraction product. I told it's a crude product. It is not purified product, purified solution. It's not purified. It contains a lot of impurities, right? After identification process, we confirm this particular compound, our required compound contained in this crude product. That means extracted product contain this whatever compound, right? Our required compound. අපිට ඕනේ compound එක මේක තියෙනවා, extraction එක extract product එක තියෙනවා කියලා we can confirm. We can get some confirmation, right? After this confirmation, we can separate and purify in the final process. Purifying mean actually we removing impurities and separate the required product, the required compound. Okay, we have three main purification methods. Three main purification method. The first one, recrystallization. They are very simple methods. Recrystallization. And we have another one, sublimation and deposition. Deposition. Final sublimation also part, right? Sublimation and deposition. Final one, distillation. Okay, that's the summary. This is a summary of the lesson. Come to the first lesson, first topic, extraction. Secondary metabolites extraction. Secondary metabolites extraction. Okay, what's the meaning of the extraction first? Extraction means whatever plant material or animal or whatever organism. Think in this extraction process, mainly we focusing about extraction from plant material, right? Because a lot of medicinal value and a lot of valuable secondary metabolites contained in plants. Cinnamaldehyde, gingerol, gingerberine, citronellol, what else? Vasicin and vasicinone. Yeah, many types of secondary metabolites, right? Nicotine, histidine, morphine, codeine. Yeah, they all are secondary metabolites, right? They all contain in plants. Okay, actually in this lesson mainly focus about extraction from plant, secondary metabolites extraction from plants. Okay, now think we have cinnamon leaves. These are plant material, cinnamon leaves. I want to separate cinnamaldehyde. I want to extract cinnamaldehyde. Then this cinnamon leaf. From this cinnamon leaf, if we can take a solution, if we can take a final solution that we call as fruit product, the extracted final product that we call as fruit product. The meaning actually not pure solution, impure solution. That's why we call as fruit product. Actually, this is a simple meaning of the extraction. Whatever plant material extract fruit product. Fruit product means impure solution from plant material that we called as extraction. Understood? Up to now, Samya? The separation of a crude product. Crude product means impure solution from whatever plant material that we called as extraction, right? This is a simple meaning of extraction. Understood, Tanya? Okay. Now we have three main types of extraction methods. What is our first method? First. Yeah, solvent extraction. Wait. Okay, what's the meaning of the solvent extraction? Solvent extraction. Actually, the solvent extraction very simple. You already know solvent extraction. Do you know the production of kasaya in Ayurvedic medicine? How to produce kasaya? And not powder form. Do you know the plant roots, stem parts, medicine pack? Oh, then how to extract these plant roots? Valuable. They actually that's secondary metabolites extraction process, solvent extraction. We doing in production of kasaya and production of paspangu. That's the secondary metabolites. Solvent extraction. Okay, what we doing in this process? Okay, it's very simple. Okay, first of all, we can take a solvent, suitable solvent. We have to select suitable solvent according to the production, right? According to the product mean according to the extract compound, we have to select suitable solvent. How to select suitable solvent? How to select a suitable solvent? That select according to the polarity of compounds. Think if you try to extract polar compound, then you can use water, ethanol like polar solvents. But if you try to uh, extract non-polar or medium polar solvent, then you have to go with non-polar solvents. Non-polar solvent mean benzene, ether, carbon tetrachloride, different types of non-polar solvents, right? You can't use water for non-polar compounds. Non-polar compound because these non-polar compounds not dissolve in polar solvents. That we called as a special term like, dissolve, like. Do you know what's the meaning of like, dissolve, like? Like, dissolve, like. What's the meaning? That was exam question, exam MCQ question. What's the meaning of like, dissolve, like? Like, dissolve, like. Like, dissolve, like mean polar compound dissolve only in polar solvents. Polar compounds dissolve only in polar solvents. Non-polar compounds dissolve only in non-polar compounds. The compound dissolve in solvents according to the polarity. According to the polarity. Okay, this is the meaning of like, dissolve, like. Like, dissolve, like mean compound dissolve in solvents according to the polarity. Polarity එක මත තමයි solve වෙන්නේ කියන එක තමයි like, dissolve, like concept. Okay, according to the like, dissolve, like concept, the first step you have to select suitable solvent, right? We have to select a suitable solvent. As I got first step according to the polarity, right? Okay, now think you are going to prepare a paspangu. හරිද? paspangu හදන්න යන්න. එතකොට these compounds are polar. Polar compounds we are going to separate. Then you can select water as a solvent. Water. This is a solvent. You selected water, polar solvent as a solvent. Understood? Understood? Up to now? Dihini? Udanya? I got tutes. Tutes sambunada. Oh. Oh, I posted Monday. I think today, due to adverse condition, the rain is anything. Okay, however, you can collect tomorrow now. I have already posted for all. Yeah, Monday morning I posted. Okay, no problem. Anyone? Kabir? Not yet, no? Tania? Hampunad? Part of that? Oh, okay. I have tracking numbers. I'll let me check after class. Most probably due to today rain, I think. Okay, everyone, tomorrow morning you can check your post office. You have 3 tubes this time. 3 tubes. You don't need to. Uh, you don't have any payments. I have already paid. Okay. Okay. The like dissolve like mean compound dissolve in solvents according to the polarity. No problem. This extraction is a practical. Okay, you can understand step by step and you can create a may prepare a short note. Then when you receive, when you collect tubes tomorrow morning, you can complete read and understand, right? Until that, you can use PDF. You all have PDF, no? I will send PDF. PDF එක දාලා තියෙනවා. Okay, I have sent the PDF into group.
නුවර ආයතනයේ කරපු කෙනෙක් දැන් නම් ළඟදී මට ඒසව හම්බුනේ නැහැ.
Okay, sorry. Again disconnected. No? Hari. Okay, I have sent the PDF. You can use PDF only for today. Tomorrow definitely you can collect it. If not, let me send me a message. Okay, no need tunes. Today we have practical session. Hari. Okay, now we are doing a very simple practical solvent extraction. The solvent extraction is a very simple thing. It's produce Ayurvedic kasaya and in solvent extraction, the first step, select a suitable solvent. The suitable solvent, how to select suitable solvent according to the polarity, according to the principle of like, dissolve, like. What's the meaning of like, dissolve, like? Compounds dissolve according to the polarity. Compound dissolved in solvents according to the polarity, right? According to the polarity. Hari. Okay, now I have select suitable solvent according to the polarity, like according to like dissolve, like concept. I have select a suitable solvent, right? Okay, then what? Then I have to introduce plant material into this solvent. They are the plant material. They are the plant material. Plant material. Plant material. Plant material. Think I just want to separate vasicine. Then they are the Adathoda plants, plant leaves and stems. Adathoda plant material. Okay, then we can heat this solvent. We can heat this solvent. We can heat. In the heating process, when it is heating, the solvent solubility ability is increasing due to high temperature. This reaction, the contact speed is increasing. Then this compound dissolve in the solid, not only secondary metabolites, all some possible compounds in this plant material dissolve in the solvent. If you want to accelerate this, we can mix this, right? We can mix this solution, right? We can stir. Okay, after relevant time, after required time, think 1 hour. After 1 hour, we can separate this plant material from solvent, separate plant material, and we can filter out the solvent. Filter out the solvent. Filter out. Filter out plant material, and we can separate the solvent. Separate the solvent. This is a solvent with secondary metabolites plus impurities. Secondary metabolites plus impurities. This is a crude product. This is a simple solvent extraction. What I did, I selected a suitable solvent and added plant material into this solvent and heated. This heating time depends on the plant material, right? It is according to the plant material, it has given recommended time to heat it, right? I think it is 1 hour, 2 hour, 4 hour. That depend on the plant material, right? Okay, when it is heated up to a certain time period, then we can filter out plant material and separate the solvent with secondary metabolites and other impurity materials. This complete impure solution we call as a crude product. This is the simple solvent extraction. This is the solvent extraction. Okay, I got the solvent extraction. Are you good? Kabir? Okay. Okay. Go to the tute. Okay. Interest of importance of extraction. Interest of directly using plant parts. Okay, that we already discussed. Some in ancient time, before 150 years ago, people use directly plant material as medicine and other requirements, right? But that was a lot of side effect due to, because this plant material not only contain relevant compound, it contain impurity compound as well other additional compounds. They, due to that coming side effects when you take any medicine plant material, if you got as a medicine, sometimes due to this plant material coming side effect, it's a medicine but it's coming side effect due to these other compounds. That's the main issue, right? Therefore people try to isolate active compound, isolate separate secondary metabolites and use as extracted compound. Then it is easy to use and accurate dosages. We can get accurate dosages and more effective treatments without side effect. And it's a conservation of plant resource. Yes, after this extraction, we can produce these compounds in chemically synthesized method. I will explain in the end of lesson. Okay, after extraction, we can chemically synthesize. Then we can conserve. We can protect our plant population. If we use as plant material, it's continuously we have to depend on plant material, right? But after extraction, we can produce this relevant compound in chemically synthesized method. Okay, then we can conserve the plant resources. Okay, method of extraction of secondary metabolites from natural sources. We have three methods. I already given methods. The first one, solvent extraction, pressing with wax and distillation. ඒක fill කරගන්න tube සම්මුණාම. Okay, this is the first one, solvent extraction of secondary metabolites. Okay, our first steps, I have given step by step, preparation of plant material. Okay, in the preparation of plant material, if we can cut this plant material, this is kinetic chemistry we discussed. If we can cut this plant material in these small pieces, then the reaction surface area is greater, right? The contact surface area with solvent is greater. Okay, think plant parts, leaves, bark, flowers, roots we can use. And first we have to clean this plant material and dry well and cut into small pieces to increase surface area. Then we can increase the efficiency of the solvent extraction process, right? In the second step, select suitable solvent. Since compound has different solubilities, suitable solvent, this keyword is very important. Suitable solvent must be selected. Types of solvent. If it is polar compounds, we can select polar solvent, water, ethanol like. If it is medium polar solvent, we can select medium polar solvent, acetone. If it is non-polar solvent, hexane, carbon tetrachloride, ethane, right? The principle according to the like dissolve like. What's the meaning of like dissolve like? Compound dissolve according to the polarity. So polar compound dissolved in polar solvent and non-polar compound dissolved in non-polar solvent, right? Okay, this is extraction process. Material is mixed with solvent. After that, desired compound dissolve in the solvent, forming an extract that we called as a crude product. Okay, that's the meaning of simple solvent extraction. Okay, what's the first step? Select a suitable solvent. In the second step, plant material washing, drying, and cut into small pieces, and heating. In heating process, what happens? This compound in plant material dissolved in the solvent. After that, we can filter out plant material and get the crude product. This is the solvent extraction. Okay. If you have any doubt, you can ask now about solvent extraction. Very simple. Fatima, understood? Junel? No, you know. You can make a short note, right? Steps of solvent extraction. What's the first step? Preparation of plant material. Select suitable solvent. How to select? According to like, dissolve, like concept. Finally, heated, then filter out plant material. This the filtered solution is a crude product. Filtered solution is a crude product. Very, very simple. Right? Great. Okay. But sometimes it's coming a problem. The problem is it's only adding solute. It's a very simple technique, no? Just adding solvent and heating and uh, filter out plant material and get the solution. It's very simple method. Sometimes it's coming an issue. It's coming a problem. The problem is sometimes these compounds, particular compounds, solubility is very low in solvents. Then if we filter out and get solution, what happened? Lot of particles wasting with plant material, right? The solubility is very low. I got. Again, heat karata. If we heated as a batch method, it's a batch method. Heating and filter out and get the solution. In filter out method, it is possible to waste lot of valuable compound because they are low solubility. Some compounds, their solubility is very low. Okay, in these cases, solvent extraction, this simple solvent extraction is not the suitable method. It's wasting lot of valuable compounds. Understood? It's wasting lot of valuable compounds. Okay, therefore, we have another advanced solvent extraction method as well. This method we called as Soxhlet extraction. Understood? This method we called as Soxhlet extraction. Soxhlet extraction. Actually, you don't need to tutes. You can have a short note. Short note එකක් හදන්න හෙට tute සම්මුණාම හරි. Okay, Soxhlet extraction. Soxhlet extraction. Actually, why we want to use Soxhlet extraction? This is a simple solvent extraction, right? This is a simple solvent extraction, but if it is the solubility of particular compound is very low, it's wasting lot of valuable compound with filter out method, filter out steps. Okay, for as a solution for this problem, we can use Soxhlet extraction method. Soxhlet extraction method. Remember, I think 2 or 3 essay questions came related to Soxhlet extraction. Okay, I'll explain step by step. In Soxhlet extraction method, we have kit of apparatus. We have a set of apparatus. Okay, I will explain one by one. First of all, we want a heater. Heater. It's a specially designed heater. It's specially designed heater for it's a electric heater. Specially designed heater for round bottom flask. Okay, this is a heater. It's contain heating coil, right? This is a heating coil. And this is a round bottom flask. Round bottom flask. මෙයා තමයි round bottom flask එක. This is a round bottom flask. Okay, and we have to fill the solvent up to this level, approximate half we can fill the we can fill up to 2/3 තුනෙන් දෙකක් අපිට fill කරගන්න පුළුවන් 2/3 of solvent right. This solvent should be a suitable solvent according to the polarity, right? According to like this or like principle, suitable solvent I selected and fill into the round bottom flask. Okay, but not plant material add into this solvent. It's another container, right? Okay, now make it okay, this is a round bottom flask. And this is a vapor carrying line, vapor transferring line. Okay, you have to draw this apparatus kit because you have to understand this very carefully because 2 to 3 times the same question came in the exam. Water vapor transferring line, vapor carrying line. And this is the remaining part. Please draw this diagram. It is the diagram given in the tube. You can refer it. Okay, this is a capsule actually. Capsule means it's a like a small beaker, plant material, and this is a filter paper. Filter paper or tissue එකක් දාන්නත් පුළුවන්. And they are the plant material. The plant material in this capsule. They are the plant material, right? Resin leaves or Adathoda leaves, right? These are plant material. And the solvent line connected to this solvent vapor line connected to this point. Like this. Yeah, like this. And there is a special line here that we called as and මෙතනින් start වෙන්නේ Yeah, that we called as siphoning line or siphoning tube. Siphoning tube. Siphon tube. Siphon tube. Siphon tube. Siphon tube. Siphon tube. And this is vapor transfer line. Vapor transfer line. Vapor transfer line. Oh, pipe, right? Vapor transfer pipe. And the remain part connected to a condenser. 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 Okay, this is the shape of condenser. You know, Ligby condenser, no? The name Ligby condenser. Ligby condenser. Okay, this is a condenser. Right. Okay. This is a Soxhlet apparatus system. මේකට ටැග් මේක හරියට තියෙන්න ඕනේ. ඔයාලා එහෙම අඳින්න. And this is a condenser. It has water inlet and water outlet. Water inlet and water outlet. Water inlet and water outlet. Or coolant inlet and coolant outlet. This is a water out. Cold water out. This is cool water in. Water in. Water in. Water in and water out. Right? And they are the plant material. Label කරමු. This is a condenser. 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 And this is the capsule. Sometimes it is made by papers. Capsule. 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 Capsule means just capsule shape එකක් වෙන නිසා තමයි අපි අර capsule. Capsule. And there is a filter paper or tissue paper. Filter paper or tissue paper. Tissue paper layer. Okay, that is a structure of Soxhlet extraction. Okay. Okay, please draw this structure. I'll explain one by one, step by step. Draw and label clearly. If not, you can't understand. Amina, complete? Okay, if you want, I will show you the clear diagram. This one. This is a heat structure, round bottom flask, solvent transfer line, and condenser. And this is a paper thimble mean capsule, and plant material, and this U-shape line we called as a siphon tube. Siphon tube. Okay, complete. This is water inlet and this is water outlet or coolant outlet. No. They are not asking to draw this type diagrams. They are asking to identify parts මෙහෙම ඇවිල්ලා තියෙනවා. මෙහෙම ඇවිල්ලා තියෙනවා. A and B, C, right? Identify A, B, C. They provide this diagram and asking this type question. And what are the purpose of C part? What is the purpose of C part? And what is the purpose of A part? What is the function of A part? And explain the mechanism of soft thread extraction apparatus. This type questions asking, but not asking to draw these diagrams. එහෙම අහන්නේ. But if you draw this type diagram, it is easy to remember parts. That's why I told to draw this apparatus. Okay, I complete drawing. Complete. Yenul. Amina, Tanya, complete, right? Okay, now clearly understand what is the process of soft thread extraction. In soft thread extraction, බලන්න. Okay, this is a condenser and this is a coolant out. It is not cooling, coolant in, coolant out. Water out. It's in. Water in. And this is a condenser and I'll draw on my diagram. Okay. This is soft thread extraction. Okay, first we have to switch on the heater. Switch on the heater. Switch on the heater. Switch on the heater. Okay, what happened? The only vapor is heating. Only vapor is heating, right? Vapor heating. And after some time, the vapor start to evaporate. The vapor start to evaporate after passing the boiling point. Okay, now can you see for this vapor 1, 2, 3 main paths to transfer. Then what is the most easy method to transfer vapor? Then make it යන්න පුළුවන්, make it යන්න පුළුවන්, make it යන්න පුළුවන්. There are 3 open areas, 3 open paths. What is the most easy one, easy method? This left side, sir. Left side. Therefore, vapors, solvent vapors transfer in this path. This path, this red color path. Because it's a free path. Okay, right? This red color path flowing solvent vapors. Then solvent vapors accumulate and collect in this plant material container. And they contact with solvent vapor, contact with plant material, right? Solvent vapor contact with plant material. Same as plant material, you have to prepare. We have to wash well and dry and cut into small pieces. We have to place on a capsule, right? And place inside the place below the condenser in the solvent soft thread extraction. Okay, then solvent vapors transfers through solvent carrying line, solvent transferring line, and it is accumulated, collect in the plant material chamber. Finally, when it is increase the quantity, it start to solvent vapor start to, after this accumulation, it start to flow into the condenser. This condenser has a continuous cooling process. Actually, the cooling is a purpose of using condenser. Okay, in the cooling process, what happened? What happened to this water, solvent vapor? Solvent vapor convert to, in cooling method, it's what happened? Condensation. In the condensation process, solvent vapors again convert into liquid. I will draw liquids in blue color. Then solvent liquids again flow into the downward and collect into the, they are solvent vapors. Red color solvent vapor, right? Red color solvent vapor, solvent vapor. After condensation, it is blue color. This condensed water, not water, called condensed solvent liquids, again fill into the uh, plant material chamber. Plant material chamber. Okay, it is the same process continues. Continues the same process. Evaporates and condense and collect into a plant material chamber. Then solvent fill to up to this level and up to this level, up to this level. No issue. Filling. Continuous filling. Continuous filling. Continuous filling. But when it is past this level, this U shape line, this point, it's coming pressure difference. It's coming pressure difference, and within 0.1 second, within less than 1 second time, it's directly come to the siphoning process. It's directly come to the solvent chamber again. This is a solvent chamber. Solvent chamber. Understood? Then again, starting beginning, again evaporating, vapors accumulate in the vapors accumulate in plant material chamber, and again going through the condenser, condensation, again fill into plant material, filling, continuous filling, and again siphoning, and again flowing, again siphoning. It's a cyclic process that we call as refluxing process. That's a refluxing process. Okay, that's why I call, that is the advantage in simple simple solvent extraction. Plant material only contact one time. Plant material only contact single time with heated solvent. But this time in substrate extraction method, so solvent and solvent vapor both contact with plant material several times. It's a continuous process. But previous method is a batch type process. I got the difference. Udanya, I got the difference. The previous simple method is batch type process. It's not efficient method, but substrate extraction is efficient method. It's solvent vapor and solvent both contact with plant material several times, not only one time, not single time. Tanya, understood? Amina, Rehlan, clear? Okay, what's the purpose of this substrate extraction? We can solve maximum amount. We can't fill all materials. Actually, we can't solve all material in the solvent. Actually, we can't get plant material contain all compounds. We can't. It is impossible process. Solvent it's impossible process. But in solvent extraction, it refluxing method, continuous method. Then we can get maximum percentage of compounds we can collect into the solvent and finally into the crude product. Then the wastage is very low. I got? Janul, understood? Can you after the vapor gases through the left side tube? Yeah, what vapor gases evaporate and going through the left side tube. That's a vapor transfer line, right? Because that is a free path. Other path I making because it has a U-turn. It has disturb, right? And this part also plant material, it has a disturb and tissue paper. Okay. Due to that, vapors always transfer through the free path without disturb. Making gihilla මොකද වෙන්නේ? Plant material accumulate in this solvent vapor accumulate in the plant material chamber. මේකේ එකතු වෙනවා. When it is collect in this container, it's part of solvent vapor going through the condenser. The condenser is a cooling process. It's doing a cooling process. It's provide continuous water in and water out, water in and water out, water in and water out. Okay, it's a full cooling system actually. In the cooling process, what happened? In the cooling process, this vapor convert into liquid that we call as condensation. After condense, this condensed solvent vapor again fill into the plant material chamber. Plant material chamber continuous up to this level. When it is come to this siphon tube level, it's coming pressure difference. Due to this pressure difference, within less than 1 second time, it's directly siphoned into the solvent chamber again. Then again continue this process. When it is filled up to this level, again siphoning, it's continue. That's why we call it as refluxing continuous process. Understood all? Remember. Hi. Now I will show you these all apparatus and how to do this practical in laboratory level.
Process. We demonstrate extracting nicotine from tobacco using ethanol.
This is a nicotine extraction process, right? Do you remember nicotine is an alkaloid type? I think you can remember. Nicotine extraction abbalam කොහොමද කරන්න කියලා. Okay, nicotine water soluble or not? Nicotine is only alkaloid. It is soluble in water, right? Do you remember? I think. And what is the source of nicotine? Which plant we can extract nicotine? Which plant contain nicotine? Tobacco, yes. Tobacco. Can you hear this sound?
Extractor allows for efficient extraction of compounds like nicotine through a method of continuous solvent washing, facilitated by its unique siphon mechanism. We begin by preparing our apparatus. Our setup includes
this is siphon
extractor, solvent condenser, a round bottom flask.
Okay, this is a heater.
200 grams of ethanol, boiling.
This is a heater, right? This is a heater, specially designed heater, and this is a round bottom flask.
For smooth boiling.
And filled solvent.
Utilizing a transparent glass sample holder with a glass-free filter for visual.
This is a plant material container. Plant material chamber.
Traditionally, opaque cellulose thimbles are used. In this demonstration, we use commercial-grade filter cigarillos, prepared by cutting them into 2 to 5 millimeter pieces.
That tobacco means doom color, right?
1.3 grams of this tobacco is
okay. Then plant material is stored in this container, right? This why they cut into small pieces to increase the contact surface area. Then we can increase efficiency. They all are exam questions. මම explain කරන්න හරිද? මේ ඔක්කොම අහලා තියෙනවා. Second.
ensures that the sample holder slightly extends above the soft solvent outlet tube, a critical setup requirement for proper function. A 0.3 grams of this tobacco is placed into our glass sample holder.
Okay.
This
Place.
setup ensures that the sample holder.
Yeah, is nicotine place. Sorry. Nicotine cut into small particles. Why? Sorry, tobacco cut into small pieces. Why? To increase the surface area, right? And place in the plant material container chamber. In the capsule. Yeah, this is a capsule.
3 grams of this tobacco is placed into our glass sample holder. This setup ensures that the sample holder slightly extends above the solvent outlet tube, a critical setup requirement for proper function. The assembly process involves placing the sock-slit apparatus.
Oh. Today our Wi-Fi is not working well.
On the round bottom flask and attaching the olive condenser on top. The condenser is connected to a chilled water recirculator set at 5 degrees Celsius. Short.
Give me a second, let me check.
This is onto the tobacco sample. Other soluble bypasses the sample, condenses in the condenser, and percolates through the tobacco, dissolving nicotine. Solvent, now enriched with nicotine, 78 degrees Celsius, ensuring that the ethanol is placing the sock-slit apparatus on the round bottom flask and attaching the olive condenser on top. The condenser is connected to a chilled water recirculator set at 5 degrees Celsius, ensuring that the ethanol vapor condenses efficiently and drips onto the tobacco sample, dissolving nicotine and other soluble compounds. Ethanol, with a boiling point of 78 degrees Celsius, is heated until it vaporizes.
Yeah, they have used ethanol as a solvent, right? Ethanol as a solvent.
The condenser,
please go to this arrow. Go to this arrow, they explain the solvent transferring path.
Ethanol, with a boiling point of 78 degrees Celsius, is heated until it vaporizes. Vapor bypasses the sample, condenses in the condenser, and then percolates.
Again put into nicotine, right? Then it is continuously filling into this chamber.
Once the solvent reaches the cycle's peak,
when it is reached to this level, that's a siphoning process.
This continuous process
again continuing. Again continuing.
The duration of sauce
again siphoning, right? That's a cyclic process.
Ethanol, a few hours to overnight is typical. After extraction, the solvent can be removed via rotary evaporation.
Okay, this part, okay. I got? I clear? Yeah. Solvent transfer to the condenser, solvent vapor evaporate and vapors transfer to the condenser, and this condensed water or liquids again fill into the plant material container. When it is filled up to siphon tube, it is siphoned into solvent chamber again. This process continuously continue. That time period also depend on the plant material to material. This time period make a activity in a time period එක වෙනස් වෙනවා. That's change according to the plant material and material solubility, compound solubility, right? මෙතන siphon 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 tube. Okay. Okay, that was an exam question 2017, I think. That was an exam question. Why this condenser, Levy condenser, what is the, why it's water inlet downward and water outlet maintain at upward? What is the reason for that? That was an exam question. Can you explain, anyone? Can you explain, anyone? Why always we need to maintain water inlet outward? If we change that, what's the coming problem? Because then issue if I change the side of water inlet and water outlet. What's the coming issue? Can anyone explain? Okay, if I change the side, water outlet, it is outlet now. Water inlet. Can you explain? Water vapor will go out before reach condenser. Yeah. What's the reason for that? Yeah, that's the actual problem. What's the reason for that? Others, Tanya, can you try? What's the problem coming if it is water inlet upward and outlet downward? Yeah, all you can try. What's the problem coming if we change the water inlet and outlet sides? That was the exam question. You know? Then what's the coming problem if I change the side of condenser, water inlet and outlet? That means water inlet out upward and water outlet downward. Quickly. Don't have time. Kabir, Fatima, what's the problem come? Why it is not recommended? Actually, it is not a recommended method. The recommended method, inlet downward and outlet upward. Proper condensation does not occur. Why? Yeah, you are correct, but you have to explain what is the reason. Why? Why proper condensation does not occur? Right. Yes, great. Yeah, Tanya correct. Yeah, Tanya correct. Great. Okay, what happened actually? If you provide water upward, then if it is out downward, the provided water directly outward. Think if you fill water this line, what happened? The provided water in same rate it is going out due to the gravity. Due to the gravity, අපි මේ උඩින් fill කරන ටිකම යටින් out වෙනවා. Right? Then is it coming a cooling purpose? No, it's not cooling there. I got. But if we provide water in downward, what happened? Filling, continue filling, and only additional amount going out. Always, therefore, your proper answer, market scheme එකේ තියෙන විදියටම ලිව්වොත්, if you provide answer according to market scheme, to make sure always fill the condenser with water. That's the answer. To make sure always completely fill the condenser with water. Then මෙහෙම වතුර දුන්නත් මොකද වෙන්නේ? ඒක completely fill වෙලා තමයි හැම වෙලාවෙම තියෙන්නේ. Always it is completely filled with water. But if we provide water in upward, it's provided water out from downward due to the gravity. Then always condenser empty. Understood, Udanya? Therefore, your answer should be to make sure condenser completely filled with water always. Always condenser completely filled with water to make sure, right? Tanya, you are correct, but your answer should be updated like this, right? Understood, Terma? Right. Wait. Okay, that is a solvent extraction. Okay, after this siphoning process, and if it is continue, think if we continue this process 3 hours, after 3 hours, we can separate this solution. We can filter out and get the crude product. This is a crude product of solvent extraction. Simple method or Soxhlet extraction. Simple method we can use for easily soluble compounds. If it is this compound easily soluble in particular solvent, we can use simple solvent extraction. If it is not easily soluble and considerable amount wasting, we can use Soxhlet extraction with refluxing method. Refluxing method. Okay, if you have any doubt, you can ask, and if you want anything, you can note down and mark anything. I'll give you 1 minute. After that, we are going to next extraction method. Udarna? Okay, if you have any doubt, now you can ask. Quickly ask. Now 8:70. Okay, everything okay? Yanul? Amina? Everything okay? Okay. Okay. Come to next method. The Soxhlet extraction and solvent extraction completed. Yeah. Second method, the extraction of secondary metabolites, pressing with wax method. Pressing with wax method. Okay, actually, this method used to extract essential oil. Why? I told essential oil, all essential oil, no specific color, and they all are volatile and they have specific aroma. Okay, they are the characteristic. They all are volatile compound. Then can we heat and use solvent extraction for essential oil? Yeah, we can nicotine, alkaloid, vaccine type compounds. We can add to the plant same. We can use for solvent extraction. But we can we use rose oil? That means ethanol extraction by solvent extraction? No. Why? When we heating, what happen? First, essential oil evaporate. then we can't separate. We can only separate carbohydrate, only impurities we can separate. Our product will be destroyed and wastage. Wastage, it's evaporate. Okay, therefore, essential oils we can't use this heated methods. Heated methods we can't use for essential oil. That's why this pressing with wax method we have to use for essential oil, volatile compounds. Volatile compounds mean essential oil. Hari. Enna lesson ekata? They commonly known as essential oil. Hari. Let's first understand the practical. It's a very, very important practical. Keep parak exam ke harti. Several times asked in exam. Hari. 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 Come to the practical. Pressing with wax. Okay, in this pressing with wax method, first of all, we need 2 glass plates. 2 same type, 2 glass plate on. 2 glass plate. Same type, same size, 2 glass plate required for this process. Hari. අපි මෙන්න මෙහෙම glass plate දෙකක් ගන්නවා same size. Same size. Hari. Now think this is a glass plate, right? This is a glass plate. And the laboratory, the laboratory contain, the laboratory have paraffin wax powder. It's in powder form. Paraffin wax. Okay, we can take some required amount of paraffin wax into a container and we can heat this. In the heating process, what happens? This paraffin wax melting and convert into liquid. Paraffin wax convert into liquid. Paraffin wax. Paraffin wax. Paraffin wax, when it is heating, it's convert into liquid due to the melting. Melting and convert into liquid. Okay, then I can get the first glass plate. You can get the first glass plate and add part of melted paraffin wax onto this glass plate, right? And you can make a thin layer. Make it api tikak dana mehema. Then you can create a thin layer on this glass plate. Mehema api awa ganna puluwan. Harida me widiyata you can create a very thin paraffin wax layer on first glass plate. Understood up to now? Very simple. Just understand as a practical. First one, select 2 same type glass plates on laboratory. Then glasses dekak ganna. Then take required amount of paraffin wax and melting. Melted liquid, paraffin wax liquid, add onto first glass plate and make a very thin layer. Again, අපි මෙහෙම ටිකක් දාලා මේක මෙන්න මෙහෙම යවා ගන්න. Then we can make a thin layer on this glass plate. Thin paraffin wax layer. Understood? Understood up to now? I would update, otherwise you will confuse. Okay. Now, take the second glass plate. You can add the remain paraffin wax, put onto the glass plate and make again same method, make a thin paraffin wax layer on this glass plate and keep some time for cooling. In the cooling process, what happened? In the cooling process, again we can see it's making a thin layer of wax, paraffin wax, thin layer make on the glass, both glass plates. Okay, they are the thin paraffin wax layer. Thin paraffin wax layer. Up to now, okay, right? Thin paraffin wax layer. Thin paraffin wax layer. Thin paraffin wax layer. Paraffin. PHION. Okay, no problem. Paraffin wax. Thin paraffin wax layer. Thin paraffin wax layer, preparing both glass plates. Right. Next is step. Okay, let's take an example of rose soil. Rose soil is essential oil. It contains citronal oil. අපි citronal oil separate කරන්න යනවා. Okay, for separation of citronal oil in now when it is cooling, the glass plate is now in the cooling process. In cooling process, it make a solid thin wax layer. Right? Take up a cool වෙනකන් you can take rose flowers and separate petals. Petals කියන්නේ පෙති. Separate petals. Petals ටික අපි ගලව ගන්න පුළුවන්. Right? Okay. After that, now petals already, now not petals, now glass plates already solidified now. It has a very thin solid paraffin wax layers. Then you can get these glass plates. You can get these glass plates. You can get this glass plate and rose petals lay on this glass paraffin wax. They are the rose flower petals. Made plant material, right? මේවා මේක උඩින් මෙන්න මේ විදිහට තියෙනවා. Rose petals lay on the solid wax layer, right? Same method. The second glass plate also doing same thing. The remaining amount of petals lay on the remaining glass plate, right? Right? Perfect. Up to now, okay. I got 2 glass plate and make a thin wax layers and keep some time for cooling. After cooling, lay solid plant material on this both wax layers, right? After that, think they are the 2 glass layers, right? They are 2 glass layers with petals. They made the petals thin. Then මෙහෙම අපි තියෙනවා. They are the wax layers, both wax layers put like this. And we can apply rubber bands. මෙහෙම අපිට rubber bands, or we can apply rubber bands, or in laboratory there are clips තියෙනවා. ඊට පස්සේ මෙහෙම දාගන්න තියෙනවා. Okay, now this is our system. This is our pressing with wax method. Now it is pressing. If you want, we can have some weight for more ensure the pressure, right? එහෙම නැත්නම් මෙතන clips දාගන්න පුළුවන්, right? We can use clips for pressure. Understood up to now? Okay, then both these layers keep as same layers, right? And keep some 24 to 48 hours. That these time periods always depend on the plant material. For rose flowers, it is normally 24 hours is a recommend. 24 hours we can keep these 2 wax layers with pressing. Understood up to now? Give me a second. Okay, up to now, okay. Pressing with wax method. Kabir. Hari. Now we have placed both the wax layers and with pressing. Pressing. We can use clips or rubber bands, or we can have some weight. Okay. However, we can press these both wax layers with plant material. Okay, this is a wax method. Okay, still not completed. Okay, still doing process. We can have 24 hours. We can give 24 hours for this process, right? 24 to 48. This time allocation depend on the plant material, right? For rose flowers, it is the recommended 24 hours. Okay, after 24 hours, that means next day. Next day, we can separate these glass layers again, separating separate these glass layers again, and we can collect these glass layers with plant material, with rose flowers. Separate this glass plate again, and we can remove the now plant material. Rose petals we can remove. Dating iron karna. Remove plant materials and collect wax. Wax part you can collect into a beaker or contain. Can scratch. And make a surla iron karna. No, it's like a layer. You can separate it because it's a wax. No? Wax as a layer you can remove and collect into a container, right? Okay. Now, actually, what happened? What the actual process happening during this process? Okay, actually, in this pressing time 24 hours, what happened? These petals, these plant material contains secondary metabolites compounds absorbed by wax during this pressing period. Okay, actually this is the store. Okay, now if we collect this wax into the another container, this wax contain whatever secondary compound and other impurities, or all compounds goes to the wax, right? Hi. Now this is a wax with compounds. Okay, after that, the final step, we can add ethanol amount. This is a wax. This is a collected solid wax. Then we can add ethanol. Ethanol as a solvent, we can add ethanol into this. Ethanol. Why we select ethanol? Because ethanol is easily evaporated at very low temperature. Okay, we can add ethanol into this. Ethanol mixed එකක් දානවා. Ethanol. As a solvent, we can add ethanol. Okay, after ethanol adding, we can heat this. Okay, in the heating process, what happened? In the heating process, again this paraffin wax melting, and the wax contained compound dissolve in ethanol. I got in the melting process, wax melting and wax contained compound dissolve in ethanol. Okay, again next process, again we cool the system. This beaker cooled by using ice. Then what happened? Again wax layer solidified, wax layer freezing, wax layers convert into solid, and this is a solvent. Solvent contain the ethanol contain the compounds, whatever the required compound and other impurities as well. I got. After that, if you want, we can evaporate ethanol and get the crude product. Evaporate ethanol and get the crude product. Okay, do you have any doubt? You can ask now if you have any doubt. Okay, that's a complete story of pressing with wax method. Okay, if you want, I will summarize again. Get 2 glass plates and make thin wax layers using paraffin wax, and lay plant materials, rose petals on both glass plates, and keep with pressing some time. recommended time period and collect, remove plant material and collect wax into a container, and at ethanol amount, heating. In the heating process, compound dissolved in ethanol, again cooling. In the cooling process, again paraffin wax convert into solid, and finally we can separate ethanol and compounds. If you want, we can evaporate ethanol and get the crude product. This ethanol evaporation, according to the requirement, that's optional, right? However, we have a solution, that's the crude product. Any issue? Any doubt? Udanya? Now you have to remember, actually this, then I may visit here. Yes, may sure, Joe. Okay, actually, I'm explaining as a practical. It is impossible to remember as theory note. Theory with it's impossible. You can prepare as flow chart or diagrams. In your way, you can prepare as a flow chart. Make a diagram with you can keep an image like a diagram. That is the easy method. What is the first method, second method? Flow chart make as a flow chart. That's the easy method to remember this type lesson. Okay, Joel, after heating, in the heating process, what happened? Hariman Kiana. Okay, up to collecting wax. Okay, Joel, right? Okay, now I have collected wax. These are wax. Okay, then I can introduce ethanol. Ethanol as a solvent. Ethanol. And we can heat this solution, heating. In the heating process, this paraffin wax again melting and convert into complete whole convert into one solution. Ek solution right? In this process, what happened? This wax contain particles that contain compound goes to the ethanol, right? Dissolved in ethanol. Okay, after that, the complete structure cooling. In the cooling process, again paraffin wax convert into solid, and this is the remain ethanol and compounds. This is a wax. Then we can separate ethanol plus. Then we can separate this layer. This layer we can separate, and this is a crude product. If you want, we can remove ethanol, evaporate. Any doubt? You all okay? Habib? Fatima? Any doubt? Quickly. Amina, Tanya, Udanya. How about updates? Any doubt? hard. Others, Tanya? Any doubt? Yenol, any doubt? Okay. Read this tute pressing of flowers. Flowers or plant materials are placed between two glass plates coated with paraffin wax. Paraffin wax my spelling strong. Double F on it. Paraffin the double F paraffin wax. Paraffin wax. Okay, secondary metabolites and aromatic compounds are absorbed into the wax. Yes, they are absorbed into the wax in this pressing process, right? Okay, after some time, all flowers we can remove. That's the additional process. If you want a rich compound, if you want a enhance the number of compounds, we can use this replacement process. It's an additional process. We can remove after some time. That means in this experiment, after 12 hours, we can remove all flowers and again adding fresh flower petals. Okay, that's the additional step. This process is replaced several times until the wax becomes saturated. Saturated means what? Saturated. Saturated can what's the meaning of saturated? With the biochemical compounds. Biochemical compound means secondary metabolites. Saturated. 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 What's the meaning? Okay, I think BST students doing soil saturation. No? Saturated soil. What's the meaning of saturated soil? All pores in the soil filled with water. Okay, that's this type of soil we called as saturated soil with water. No? Am I correct? Fatima? Tanya? Am I correct? If all pores in the soil, if it is filled with water, normally flooding condition. Flooding it's a saturated soil. Yes. Yeah, saturated soil mean it's all pores filled with water. That's a saturated soil. Saturated, same thing. Saturated mean all pores in the wax filled with secondary metabolites. Okay, that's why we doing the same thing again and again. We adding fresh flowers to saturate the wax. Saturate the wax. Next, dissolving the wax. The saturated wax is treated with heated ethanol or ethanol suitable solvent. In the heating process, wax and secondary metabolites both dissolving, right? Both dissolving. In the cooling process, when hot solution is cooled, wax is precipitation. Wax precipitate and the desired compound remain in ethanol. These are the required compounds. That means wax contain compound dissolve in ethanol. Dissolve in ethanol. Finally, we can remove wax by filtration because they convert into solids. Solid. Obtained in the crude product. Ethanol is evaporated. Ethanol is evaporated using gentle heating. Gentle heating means we can't heat as we required because the secondary metabolites are highly volatile compounds. Therefore, we have to be very careful in the ethanol evaporation process. And remain substance is a crude product or impure product of this pressing with wax method. Okay, advantage of pressing with wax method. It is suitable for delicate flowers and preserve natural fragrance, that means natural compounds. Useful for extracting volatile oils. Yeah, that's the main advantage. We can extract volatile oil. Okay, they are the disadvantage. It's time consuming process. Yes, not like solvent extraction. It takes 48 hours. You can yeah, that's the main disadvantage. Expensive compounds to other extraction method. Expensive, yeah. Compared to Soxhlet extraction, actually is a cheap method, but compared to simple solvent extraction, it is expensive, right? It's comparative. Produces crude product that required further purification. Yes, more than solvent extraction, this means pressing with wax given crude product is little bit purified because no more secondary metabolites, because no more carbohydrate protein compound, because it's contain only secondary metabolites, little amount of impurities. The final extraction method, the distillation. Okay, come to our final extraction method, the distillation. Distillation. Okay, I told distillation we have three methods again. What are the distillation methods? Simple distillation, steam distillation, and fractional distillation. Okay, distillation methods very simple. Okay, first come to simple distillation. Distillation commonly used for method of extraction volatile secondary metabolites such as essential oil and anaerobic compound. Okay, I have issue. Why? I told all essential oils are volatile compound. Sorry. But then how to extract second volatile compounds? By distillation. After explain, you also have a problem. I know. Okay. In the lesson, I will explain in the middle of the lesson. Okay. I told distillation again, three main types. What are the types? Simple distillation, steam distillation, and fractional distillation. Right. simple distillation. Simple distillation. Okay, this is a simple distillation. This is a plant material and solvent. This is a plant material and solvent both contained in one flask, plant material and solvent. And it is flowed into a condenser and heating. Okay, in the heating process, the solvent heating and evaporating, and it's going through a condenser and collect into a container. That's a simple distillation, very simple. Okay, I will show you the distillation, simple distillation. It's very simple process. Very, very simple process. Give me a second.
Performing a distillation, first the condenser is filled with cold running water. Next, heat is applied to the mixture, which is to be distilled. The mixture is heated until it boils, and the hot vapors will travel up the distillation head. Measuring the temperature. Next, heat.
Okay, it's a simple distillation process. This is a plant material with solvent. Plant material and solvent in a same container. And it is connected at the pipe, the solvent transfer line, vapor transfer line directly connected with the condenser. Same as previous, same principle, cooling to make sure water completely filled with condenser. It's a efficient cooling system. And what happened is evaporated solvent vapor condense in the condenser and collect in this beaker. This is a simple distillation.
Filled with cold running water. Next, heat is applied to the mixture.
Yeah, this is a cooling process.
The mixture is heated until it boils, and the hot vapors will travel up the distillation head. Measuring the temperature of the vapors helps us to identify the liquid being distilled and will help to confirm its purity. If the vapors are pure, they will have a constant temperature equal to the boiling point of the liquid being distilled. As the vapors travel into
Yeah,
the
that
condenser,
the boiling point of the
liquid
vapor,
droplets, called the
it's
distillate,
flowing through the
run down the
condenser.
condenser, collected in a
Okay, these are
receiving
crude
glass.
product. Simple.
A liquid can be easily separated from non-volatile contaminants by using a simple distillation apparatus, such as this one. Since the non-volatile components in the distillation flask will not evaporate, the vapors and the resulting condensate will be pure.
Okay, this is our next practical.
In this video, we are going to learn the steam distillation using animation. The main parts of steam distillation.
Okay, I got it's very simple. Simple distillation. See, plant material mixed with water. Yeah, both in same container. And heated directly. Volatile compounds evaporate with steam and then condense back into liquid. That's why I told we can separate essential oil as well, because they volatile and again condense in a condenser in the cooling system, right? Therefore, volatile compound also we can separate by distillation method. I got. That's why, because volatile compounds not continuous wasting, because again it's converted into liquid. I got Joel, I got. Yeah, it's a simple distillation, simple technique. Plant material and water solvent in the same chamber. When it is heated, it's evaporate and going through condenser. In the condensing process, again this all vapor converted into liquid and collect in the container. This simple distillation. Simple distillation. Okay, go to the next one, steam distillation. Actually, this steam distillation, the difference in simple distillation, plant material and solvent both having same contain, but steam distillation, steam is first container and it's evaporate and it's first go to the plant material. First go to the plant material. See, this is a steam generator. This is a solvent, and solvent vapor going through the plant material, and this vapor again go through the, in the final stage, it's going through the cooling system, condenser. Finally, it's collect in the container. That's a crude product. Here, Bala. Okay, what are the advantage? Suitable for heat sensitive compounds, because it is contact with vapor, prevent decomposition at high temperature, widely used for essential oil extraction. Why essential oil easily evaporate with vapor and vaporize and again convert into liquid, then we can collect, no wasting, right? Hi, this is the method.
Using animation. The main parts of steam distillation setup include
Steam generator,
the round bottom flask, holding the liquid mixture,
liquid measurement plant material.
We see two characteristics of the steam distillation. Some of the characteristics of steam distillation method are as follows. It separates organic compound from plant source. Those organic compound using animation. First, steam is generated in a steam generator and then carefully directed to a round bottom containing the plant material and water. When the hot steam comes in,
This is unnecessary.
plant material.
In our practical, no need heat plant material, only heat solvent, right?
Inside the plants.
Okay, it's evaporate and going through plant material and again cooling, going through the cooling process. That's the steam distillation.
These vapors mixtures then travel into the water condenser. You can see on the screen. Inside the condenser, cold water circulate around the outer, which cools the vapor and convert it back into the liquid. Finally, condensed liquid is collected in a receiver because
Okay, simple. Steam distillation, right? Finally, fractional distillation. Actually, this fractional distillation we can use to separate several volatile compounds. We can separate normally. Actually, do you know what is a common usage of fractional distillation? Fractional distillation we can use for separation of purification of crude oil. Purification of crude oil we can use fractional distillation. This is a method. Fractional distillation of use karane purification of crude oil and petrol diesel separation. Using this fractional distillation, we can separate several compounds at one time. That's the main advantage. Different boiling points are present together. Compounds are separated according to the boiling points using the fractional column. For this fractional distillation, we have fractional column. I will show you. Okay, this is a fractional column. This fractional column, their heating temperature is different. Heating temperature difference. That's why in lower level it's high temperature and above it is low temperature. According to the boiling point, we can separate different compounds. Different compounds we can separate according to the boiling point in the fractional column. Okay, that's a fractional distillation. Fractional distillation very rarely used for natural product extraction. That's used for crude oil preparation, crude oil separation, purification process. Okay, that's the main usage. But fractional distillation, if you can, it's a very expensive process. If we can use this fractional distillation for natural product extraction, it's the best method for separate several compounds from one plant material, same plant material. Think we have a plant material, it's contain citronellol and several compounds, several natural products, several required valuable compounds. Then we can use fractional distillation. Okay, I'll show you, but that's not commonly used for natural products, right? Fractional distillation. Give me a second, I will show you.
Let's take an example. Separation of acetone and benzene by fractional distillation. As the difference in boiling points of acetone, whose boiling point
in two different
329 Kelvin,
boiling point,
and benzene, whose boiling point is 353 Kelvin, is only 24 Kelvin. Their mixture can be separated by the
that we call as fractional column. Fractional column and condensed. Right?
Let's see how this can be done. The mixture is taken in the distillation flask. Fractionating column is inserted between distillation flask and Liebig water condenser. The flask is heated on water bar. At a steady temperature of 329 Kelvin, acetone distills out and is collected as first fraction in the receiver. The vapors of benzene are cooled in the column and liquid benzene trickles down back into the flask. When acetone is distilled out completely, the temperature starts rising and the receiver is changed. When the temperature becomes steady at 353 Kelvin, benzene distills out and is collected as second fraction in the receiver. Acetone and benzene can be further purified by redistillation.
Okay, these are crude products separation. We got two crude product, two different several compounds, two compounds we can separate, two or more several compounds with different boiling point. I got, yeah, I think you got the idea, right? First, we heat up to a certain level, then benzene is evaporated and collect as a
The vapors of
first
benzene are
fraction.
cooled in the column
Then
and liquid
increase the
benzene
temperature up to
trickles
second
down
boiling
into the
point,
flask.
right?
When acetone is distilled out completely, the
Now it
temperature
is
starts
complete.
rising and the
Temperature
receiver
start
is
to
steady.
next boiling point, increase to next boiling point.
When the
Heating.
temperature becomes steady at 353 Kelvin,
Yeah.
benzene distills out and is collected as second fraction
Okay.
in the receiver.
Then we can separately, that's why we call it fractional distillation. Fractional distillation. This fractional distillation used to separate several compounds from one crude plant source, one natural product. Okay, the extraction methods completed. Do you have any doubt? Any doubt? Joel, Tanya, Fatima, Kabir, Udanya. Okay, please go to tomorrow morning. You can collect tubes and you can go to extraction methods again. Again, go to one by one step. What are the first step of pressing with wax? Then what is the second one, third one, fourth one? Then how to complete this pressing with wax method? What is the Soxhlet extraction steps, parts, each part purpose of each part, and distillation, three methods. Fractional distillation we use for may separate and extract two or more several compounds in one source, right? Okay, clearly make a short note and prepare for the chromatography. In Friday, I'm going to complete chromatography technique. Then 90% of lesson complete. Okay, next week we can start the next lesson, fluid mechanism. Okay, I got today. That's a today lesson. Tanya, in doubt? Jenul, any doubt? Udanya? Hari. Please prepare short note. If not, it will be very complicated, right? Tute එකේ තියෙන ඒවත් ඒව පාඩම් කරන්න යන්න එපා. Don't try to by heart theories on tute. Only make a short note and step by step prepare your own note. Then it is very simple lesson actually. Okay, let's meet on Friday evening 8 p.m. with the chromatography techniques. Chromatography is another important practical session. Okay, tomorrow you can collect tubes and work on this lesson and complete within this week. Let's try to complete the whole works of natural products. Okay, goodbye, good night.